Hello. Let me explain now in more details menu on the right, which are parameters of radio, interfaces, and let's explain on the beacons, not on the modems, because radio settings are more or less the same for beacons and modems, but in beacons there are also ultrasound. So let me explain based on the example of beacons. If I press this plus, so it expands, what I have? Base frequency is base frequency, sort of base frequency against which channels are jumping. So channels give me, you see, I'm jumping, base frequency doesn't change, but the carrier, the resulting frequency will be different. Another important element is the radio profile. Radio profile, you can choose between currently 3 preset radio profiles. For you, it's important to remember that 500 kilobit per second gives you the fastest update rate, but the bandwidth will be the broadest and the sensitivity will be the least. And it means that if you have some external interference, your system will be most vulnerable with this radio profile. But at the same time, update will be the highest. So it's important if you have copters, for example. But if you need longest distance in radio, then obviously 38 kilobit per second is recommended. 100, okay, now I made the classical mistake because the system will be now very difficult to wake up because I changed the radio profile. Now I would need to change radio profile on the beacon, on the modem as well. So I will go here, I will write it all, and now I will return to this and try to wake it up. Yes, now I see it, because you see it's 38 kilobit, but all the rest is on 500. So let me change it here, write it all. So now it's again on 500 kilobit, but I will lose it very, very quickly because the beacon, the modem is talking on 38 kilobit. So let me return back everything to 500 kilobit. So now the system's supposed to be working okay because almost. Let me try to read it. So at least it must work now. You see, I'm checking their, okay. System is back. I'm checking based on time from the reset. When the time is ticking, so it means that the system is active. And this one, okay, so time is ticking. So this beacon is also active, so everything is fine. But you see what I did. I basically switched the radio profile, and as soon as I switched it, for example, if I do it quickly and it doesn't record, then it's still okay. But if I wait for a couple of seconds, then radio profile settings, the new one, will be automatically written to beacon 6. And since that, beacon 6 will not be able to talk to the modem anymore, because modem will be talking to the beacon based on radio profile 500 kilobit per second, and beacon will be listening based on 38 kilobit per second, and they become absolutely incompatible. So be careful with this. This is why if you lose the beacon due to radio, due to some manipulation, don't worry. Just take the beacon, connect via USB each of the beacon, press default. All of them will move to the default settings and you will always be able to find them. So don't worry about that. But at the same time, be careful with these settings, because as soon as you click it, you keep it for a couple of seconds, then it tries the new radio profile, which is different from the modem, and then the modem will lose this beacon. So remember what you do or don't do until you know. So the device address, I discussed already. So the device address is basic name of the address or number of the address. Without knowing, you cannot talk to this beacon, you cannot wake it up, you cannot do anything with the beacon. So you must know the device address. Channel, there are several channels. So currently there are 4, but there will be more. it's basically channels. So you can set up the several systems, and the systems will not know that they coexist. They will basically operate on absolutely separate frequencies. So it means that if you have two systems, two modems, you can run them. But remember that they will not know about each other in radio, but in ultrasonic they will interfere if they are in the same room. So be careful. You can deploy in different rooms where ultrasonic signal doesn't propagate from one room to another. In this case, 2, 3, 4 systems can coexist very easily. It's also important if you have interference in one of these frequencies, you cannot move that interference, so you can move yourself. Change the channel and move to another frequency where there's no interference. Modulation. Once again, this radio profile is a combination of different settings. It's this modulation we chose, maximum power, so spacing. You don't need to do this at all, so just don't touch. So this is some internal stuff. You don't need this. You can of course play with this, but you must have the same settings on the beacon and the same settings on the modem, otherwise they will not be able to talk. But for the simplicity, this is why we combine them into the radio profiles, and radio profile automatically choose all this, so don't touch it, and unless you really want to go very, very deep into the radio interface. Another very important part is ultrasonic. And so in ultrasonic, there are also quite many settings. First of all, mode of work. So TX, RX normal is normal beacon settings. There are some internal settings. So TX only. In this mode, the beacon is emitting pulses of 5 periods each, 8 times per second. It's basically clicking 8 times per second. So RX only, it doesn't emit anything, it just listens to it. Again, it's more for internal debugging. Channels 8 Hz, I frankly don't remember, it's something deeper. I think it's switching this one. So don't worry, for you, this is the mode. TX, RX normal. This is element and sleep mode. By default, it's now enabled, and this is why the system is not so optimal in terms of power consumption. You can disable it, and it will be far more less consuming in sleep or in deep sleep. But be careful, because we're playing with this a lot, and maybe this feature is now disabled, so don't remember. Power of the transmission, again, some internal stuff. This is what you need to know. This must be in this mode. Don't play with this. This is internal. This is frequency, basically central frequency of ultrasonic. We are using customized ultrasonic sensors, and the central frequency of those sensors are 31 kHz. It can be different, but what you are getting now in hardware 4.9 is 31 kHz. Duty is basically meander, so it means that 1 and 0 are equal, so this is why it's 50. But you can set differently. In this case, you can play indirectly with amplitude of transmission. Usually doesn't affect much, but you can play. So duty cycle can be different. Number of periods. This is important. So when you have a small room and you want to have least echo, and you want, again, small room, use small number of periods, like 1 to 5 is for small room of whatever, 5 by 10 meters, for example. But when you have large distances, a large room, a large corridor of 30 meters or 40 meters, just type whatever, 30, 40, 50. If you go above 50, usually it doesn't help much, but if you go from 5 to 30, you will certainly see that the signal will be much stronger. So by 10 meters it's not necessary, because even 5 is more than enough, even smaller than 5 is enough. But when you have a large distance of 30 meters, 40 meters, I would recommend to move it to 30, 40 number of periods. This is for the self-calibration. You can set amplification AGC, which is recommended, but you can set it manually. This is important when you have some special conditions, or very special conditions, for example, very noisy copter flying above the sensors. So AGC may be suboptimal, so it's recommended to move in manual, and then they set receiver amplifier to some manual settings. Play with it. It's very non-linear. So if you change from 100 to 200 or from 1000 to 2000, it doesn't mean that the gain changed 2 times. No, it's very, very non-linear. It doesn't change until some limit, then it changes very quickly, and then again it's pretty flat. So play with it, use the oscilloscope to see the signal, but choose it. So this AGC setting is more or less internal stuff, pretty complex, so you don't have to play with it unless you're really aware what you are doing. So some internal stuff about the settings. Keep it is like it is by default. It's about AGC settings, it's about threshold mode. So for you, not much here, except for this gain, AGC versus manual. By default, AGC is recommended, but for some special, yes, you can play with manual settings, or actually it's even very much recommended to play with internal settings. Here, by the way, you can also set manually any of these, and it is important and it's useful when you have some special conditions. Once again, as special conditions means very noisy environment by copter or by external noise, you can reduce their gain such way that you would achieve the highest signal-to-noise ratio. Because if the gain is too high, the noise will be amplified, but the signal will be saturated, and signal-to-noise ratio will be poor. So reduce it to 2000, whatever, 200, 2000, to maybe even less than 2000 for each of these. Monitor signal in the oscilloscope. So maybe it will work even like this. So let me try. Maybe it will work. Okay, like this, for example. So this is a good signal. You see, there's almost no noise, and the signal is pretty strong. So the system operates well. But when you have too high noise will be amplified, but the signal may be too strong, and the signal is saturating, and the signal-to-noise ratio will be poor. And the solution is reduce the gain. In this case, both signal and noise will be reduced, but signal-to-noise ratio will be improved, because the noise will be reduced, but the signal will not be saturated anymore. So it means the signal-to-noise ratio will be better. So play with this. Okay, back to radio settings. Don't need ultrasonic. So gain is important. What else? This is also internal stuff, very much internal about AGC settings. You don't need to. The only thing you really need is this, RX1 settings. Check the manual. In your beacon, there are 5 sensors. RX1, 2, 3, 4, 5. 4 is the central sensor facing straight. So this is up, etc. So how it works? It works this way. For example, if I choose this one, and I disable some of them, check. You see? The signal, okay, then AGC kicks in. AGC again reduce the gain. But what first you see that the gain drastically increased. Actually, the signals drastically increased. Why? Because RX1, RX2, RX3 doesn't necessarily receive the good signal, but it loads RX4, which is receiving the good signal. It's basically the load for them. So it means that if you have RX4 facing your mobile beacon, but RX3 is facing some other direction where mobile beacon must not be or will not be, just disable it. So that will be the most optimal. So this is important for you. And there's a difference between RX normal and RX frozen. Sometimes it's important to set with Rx normal. Rx normal mode means that when you set up the map, and Rx frozen is when the map is already frozen. For example, beacon 10. Beacon 10 is facing all other beacons, and if you position the beacon like this, and beacon 4 will be looking this direction, beacon 4 having around 90 degrees angle is sufficient to cover all this territory, because it will be facing like this. You don't need to enable other beacons, because one beacon will be looking this direction, there is nothing, this direction there is nothing, bottom there is nothing, up there is nothing. So beacon 4 is generally good enough for this system. At the same time, for this beacon, beacon 4 may be not enough, because sensor 4 is not enough, because beacon 13 is looking this direction, but at the same time this is on the left, this is on the right, so it means that you would need to enable sensors RX1, RX3 if they are looking this direction, because otherwise you will not see them. But this is during the map building. But at the same time, if you have your copter flying only in this area and not flying to this area, then you don't need beacons here in their RX frozen mode. So it means that for beacon 13, in this case, I would probably choose these settings. I don't need beacon sensor 5. I probably don't need sensor 2. 5, for example, looking upward. 2 is looking downward. Beacon 4, sensor 4 is looking straight. This is looking left, and this is looking right. So I return like this. But in the RX frozen mode, if my copter is flying only in this direction, I wouldn't need this sensor, and I wouldn't need this sensor, and I disable them, and leaving only this sensor. So it's pretty advanced, but it gives you the most optimal settings. So when you build the map and you don't have noise, you use 3 sensors, looking this direction, looking this direction, looking this direction. But when you freeze the map, you use only central sensor. But keep in mind that in this case, this area will not be served, and this area will not be served. If you expect that copter will be flying this, or robot will be moving this, then you need these sensors as well. If you expect that your beacons will be serving all area, then of course enable everything. So by default, everything is enabled. It's not the most sensitive, but at least it guarantees you the widest coverage in ultrasonic. But at the same time, it means that you can collect the noise from all the directions. For example, if you have, I don't know, some source of wideband noise this direction, it's much easier if you just disable sensor looking this direction, and thus improving signal-to-noise ratio drastically. So that was about ultrasonic settings. For you, most important is this mode. This don't touch. This is important. Sometimes gain is important, and this is important. So interfaces is the same. So speed, protocol for SPI, and raw data. So you can get the raw data from mobile beacons, not from station beacons, but some mobile beacons are coming with EMU installed, and you are able to get the raw data out of them. So that's it for settings in the dashboard. If more, just ask your questions on the forum.